Yes, students, greetings of the day. So today we are going to talk about vectors two part. Okay, in vectors one we have discussed what are types of vectors, representation of vector. Okay, how to add vectors by using triangular law, and then we have gone for parallelogram law. Okay, derivation also we have done. R is equal root of a square plus b square plus 2ab cos theta. And the cases we have seen when theta is equal 0, r is equal mod of a plus mod of b, which are adding those two vectors. If r is 180 degrees, when they are in opposite directions, okay, we are subtracting the vectors. When two vectors are perpendicularly, so we are writing r is equal root of a square plus b square. Now, continuation vectors part 2, that is finding the angle made by the resultant vector with any one of the vector. That point we'll talk about here. Okay, and then we'll be going for components of the vector. So what are components, how we resolve the vector into components. Okay, how a point in the planar space can be represented in terms of components of the vector. Okay, and then we go for operations of the vector like dot product and cross product, and few basic numericals will be solving in this session, which will be useful for you all. Okay, so right, let us start the session. Okay, yes, we spoke about till here, students, resultant vectors. Okay, so r is equal to root of a square plus b square plus 2ab cos theta, and when theta is 0 degrees, r is equal to root of a square plus b square plus 2ab. That means we yielded into this result. R is equal to mod of a plus mod of b. We have seen when vectors are in the opposite direction, we have seen r is equal to mod of a minus b. We have seen this result. We have seen when theta is 90 degrees, so we have seen this result. R is equal to root of a square plus b square. Okay, and the value of r lies between these two. Now 1 minute, once again you see. So when we have two vectors, this is a bar vector, this is b bar vector, and when theta is the angle between them, and we represent them along the adjacent sides of a parallelogram with common vertex, and we designed a parallelogram parallel to a, this is a bar, parallel to this is b bar. The resultant is given by diagonal passing through the common vertex. Okay, this is r bar we have seen, and for finding the magnitude of r, we have seen that we have drawn a perpendicular here, say for example some m, and let's say r bar makes an angle alpha with what I can call a bar, and beta with what you can say b bar. Now in this one, so this vector you have seen as b. Why? These two are parallel, you can say, and when this angle is theta with the horizontal, so this is also b, so this also makes angle theta, and we have seen this magnitude is b, right? And we have seen this value x we have derived, and this value as y we have taken, and this x we have derived as b cos theta, and y we derived, okay, you can go through my previous session. So y is equal to b sin theta. Just nothing, right angle triangle we have taken, and this angle theta, this is b, this is x, this is y. So we have written cos theta is equal to x by b, and x is equal to b cos theta, and similarly y is equal to b sin theta. This derivation we have done. Now let the resultant makes an angle alpha, we are saying, right? Yes or no? So resultant angle vector is making an angle alpha. So in this triangle, say this is O, this is A, okay, this is C, you can say this is B. So OCM, right angle triangle. So what you can get tan alpha value? Tan is what? Opposite side by adjacent side. Yes or no? So opposite side by adjacent side, tan alpha. Opposite is B sin theta. So B sin theta A divided by A plus B cos theta. Why a plus b cos theta? OM, opposite side, this in this triangle, opposite side is b sin theta, adjacent side is this vector is a, this value is b cos theta, this vector magnitude is a mod a, so a plus b cos theta. So we have seen now tan alpha is equal b sin theta by a plus b cos theta. So you can write alpha as tan inverse of b sin theta by a plus b cos theta. We have seen, students. Okay, this is the angle made by resultant vector with any one vector. Clear? Now, so here you can make this tan alpha equation as 1. Now we can also prove here, students, if two vectors are of equal magnitude, if a is equal to b, if you simplify this one, so tan alpha is equal to, so this is a is equal b or calling, so b sin theta by a is equal b, so b plus b cos theta, so you take b common, so 1 plus cos theta, you can cancel this. Sin theta you can write sin 2a formula, say so sine theta you can write like this, sine 2 into theta by 2. Can you write? This to get cancelled. So you can take sine 2a form. Sine 2a formula is 2 sine theta cos theta. Sine theta, theta means theta by 2. This is cos theta by 2 divided by 1 plus cos 2a formula, students, here again. So I am going to use 1 plus cos 2a formula, 2 cos square a. Okay, you should know these formulas. Formula 1, formula 2. Okay, now if you substitute these values, 1 plus cos 2a is 1 plus cos 2a is 2 cos square a. When this is 2 theta, this is becoming theta. Okay, so here theta is, that becomes theta by 2. So 2 cos square theta by 2. This is called half angle identity. Okay, so sin 2a formula is 2 sin a cos a. 1 plus cos 2a formula is 2 cos square a. So when this is 2a, it is becoming a half. So this is theta and it becomes half, theta by 2. When you simplify, students, 1 cos theta by 2 get cancelled. So you can write down now tan alpha is equal to tan theta by 2. Whenever two trigonometric functions equal, okay, their trigonometric identity is equal, you can write on their arguments, angles also equal. So from this we understand alpha is equal theta by 2. So when two vectors are of equal magnitude, okay, like this a bar and this is a b bar, parallelogram, again this is a, again this is b. Okay, this angle theta, resultant is r. Now and this angle we made as alpha. Now what is saying, conclusion? When this a is equal to b, what we have drawn, alpha is theta by 2. So this will become half theta by 2. Total angle is theta. When this is theta by 2, this also becomes what? Theta by 2. What does it mean? That means resultant is bisecting the vectors. Very important result. Whenever two vectors are of equal magnitude, what does resultant will do? Resultant will bisect the angle between the vectors, students. Okay, simply you can take one vector resultant. So for example, 10 Newton magnitude, 10 Newton magnitude are there at an angle of 60 degrees. Okay, so find the angle made by resultant vector, he may ask tomorrow in the exam. So what you can write, parallelogram. So you can say this is resultant passing through diagonal, right? Now formula is what? So theta is equal to 60 degrees. How much resultant makes angle? Alpha. So tan alpha is how much now we have written? After if a is equal to b, tan theta by 2 we have said. Yes or no? So alpha becomes theta by 2. So simply this becomes now 30 degrees. In this case, what is resultant if you ask? Resultant how much? What is the formula for resultant? R is equal root of a square plus b square plus 2ab cos theta. A is equal to b also, isn't it? These two vectors are equal. So a is equal to b. Now you can say a is equal to b. So you can take a square plus 2a into a, again a square into cos theta. So you can take, student, 2a square. Here 2a square, to take common. So 1 plus cos theta. Again same formula I am going to use. 1 plus cos 2a. Formula is 2 cos square a, half angle identity. 2a, it becomes a. This 1 plus cos 2a. Theta I am writing how, students? 2 into theta by 2 form. Okay, so now you can understand. So which is equal to how much? 2a square into 1 plus cos 2a formula is 2 cos square a. A means theta by 2 here now. Why? So half angle identity. So 2 2 is 4, root 4 is 2, root a square is a, cos theta by 2 whole square is cos theta by 2. So you can write down here cos square theta by 2 is equal to cos theta by 2 whole square. You can write like this in trigonometry. So when two vectors are of equal magnitude, resultant will be how much? 2a cos theta by 2. Now here each magnitude is 10 Newton. So 2 into 10 into cos. Angle how much? 60 degrees. Isn't it? How much angle I give? 60 degrees. So you can 60 by 2 is 30 degrees. That is equal to 20 into cos 30 is root 3 by 2. 2 ones are 2 tens are. So 10 root 3 Newton. So when two vectors are of equal magnitude, resultant bisect the angle. Okay, one point important one. Second point is the formula for resultant. You have to remember this formula throughout these 2 years of +1 and +2 and for competitive exams. Okay, 2a cos theta by 2. This is how we find the resultant of two vectors. Parallelogram law of vectors. Okay. And next we are going to enter into a very important topic, what we can call is components of a vector. So simply remember, component nothing but in mathematics language we call foot of the perpendicular. In general, okay, non-scientific language you can call it as shadow of something. Okay, or one more point, projection you can say. In physics the same thing we are calling as component. So before understanding this, simply understand this one, student. For example, I have a pole like this with a horizontal making some angle theta. If is sunshine or some light, if you are making it to fall on this one, how its shadow falls? Come on, tell me. Yes, the shadow falls like this. This is called projection. In vector, this itself we are calling as component. Clear? Now say we are having a vertical wall here like this. Same pole is standing like this. What you do? You just sun the light or switch on the torch light like this. Where is shadow fall? Its shadow falls on the vertical wall. So this intercepting length is called local language shadow, scientific language projection. In mathematics, in physics we call component. So if you see that this particular rod or this particular pole is lying in the xy plane, its shadow along x direction is called x projection. Shadow along y direction is called what? Y projection. So you can say a vector in the plane, it can be resolved into two perpendicular components. We call this as rectangular components. What, students? Rectangular components. Okay. So what about if this pole is lying in the space or in vertical plane, you ascend it, right? Now if it lies actually in a space, so you can have three directions. So this is x-axis, y-axis, and we have z-axis. If it is in the plane or a space, so if you draw a light or when you shine the light like this, you can fall its shadow on the x-axis, its shadow on the y-axis, and actually perpendicular to this way. I cannot draw it as a plane, no, perpendicular. Imagine a z-axis towards your eyes, then its shadow on the z-axis. We can't draw, no, just I am representing over here. Like this, a vector can be, say for this vector is a bar. Okay, length of the vector you can talk as a magnitude, length of this particular pole which you have taken. Direction is this one, so vector plus magnitude. Okay, this is a component, projected length. This is x component. This is, we call it as y component. This we call it as z component. Okay, so you can also talk here, for example, this angle is here alpha. Okay, this magnitude is here a. Already you know cos theta. So cos alpha is how much, beta? Adjacent side by hypotenuse. So ax value how much? A cos alpha. Its length. On y-axis how much? Again same, this triangle you can take here. Okay, so this angle you can say 90 minus alpha, or you can also take some other different. If it is in the space, you can take this result a bar vector making an angle of some beta with y-axis. Then ay becomes how much? You can draw here ay is equal to, one side is ay, hypotenuse is a, so ay becomes what, beta? A cos beta. Similarly, z-axis also you can write az is equal to a cos, say gamma angle it is making. So when a vector in the space, okay, makes some angle alpha with x-axis, beta with y-axis, and gamma with z-axis, then the respective components are projected lengths along the direction is ax, along the direction is ay, along z direction intercepting length, okay, is how much? Az. Then ax becomes a cos alpha, ay becomes a cos beta, az becomes a cos gamma. These are called components. Okay, so now you can use triangular law for writing any vector in the space here. Okay, first we will talk about how to write a vector in a plane into what? Its components. What are components? Whenever any vector is there, so component is given by, so simply one more way of saying, you see this is tail, this is head, in which direction you want the component. Okay, this is student. So from the head of that vector, draw a perpendicular in the direction, then the intercepting length is called its x component. No sir, I want to find component y direction, sir. Yeah, please go ahead. This is a bar vector. Where is the head? This is the tail. From the head you drop a perpendicular on that particular direction. This intercepting length is called y component. Similarly, if this is z direction, this is x, this is y, this is z, right? This is y, this is z. So this is not in the plane, perpendicular to plane. So perpendicular to plane means towards you can imagine a perpendicular. Then draw from head one intercepting length. So this is a plane, I can't draw here, that's why you have to imagine here. So z direction you can see. Then this intercepting length is what? Az. Then ax, ay, az already found, a cos alpha, a cos beta, a cos gamma. If I take r cos alpha, r cos beta, r cos gamma, understanding? So these are called components of the vector. Now okay, so a vector, this is in a space. So in space, a vector can be resolved into three perpendicular components called rectangular components. So a vector in space can be resolved into how many perpendicular components? Three perpendicular components. So three rectangular components. If I ask vector is lying in a plane, they are called coplanar vectors. Okay, vectors lying in the plane. Same a bar or r bar as you wish, student. Okay, this is x, this is y. If this angle is alpha, if I draw a perpendicular, this intercepting length is x component. So rx becomes how much? R cos alpha. If I draw a perpendicular, this becomes ry. So this angle you can take as beta, or a plane, no, this angle is 90, this becomes 90 minus alpha. So you can also write r cos beta, but beta is equal to how much? 90 minus alpha. So you can write r cos beta means 90 minus alpha, cos of 90 minus theta, that is sin alpha. Okay, remember this formula in mathematics. Fine. So r cos 90 minus theta is equal to cos of 90 minus theta. Okay, this is y component, sin alpha. So beta is 90 minus alpha, so cos of 90 minus theta, no? So you can write, this is when rx, this is when ry is r cos beta, rx is how much? R cos alpha. So beta value is 90 minus alpha, so cos of 90 minus alpha. So which is because how much ry will be? Ry becomes r sin alpha. Clear? So here a vector in the plane is resolved in two rectangular components. So this is x component. Components are scalars. Okay, keep in mind, vector is there, vector components are what? They are scalars. So here r bar, rx and ry. Now see, I can write down this particular rx length and ry length in terms of unit vectors here. Now one before this, how to represent this r bar in terms of its components. So for that, remember students, already we discussed about unit vectors, right? What are unit vectors? Those vectors which are having magnitude equal to 1 are called unit vectors. So especially we are defining here three vectors, okay, in space. This is x, this is y, z. Any vector, if it is pointing along x direction, already we have seen unit vectors are utilized for finding direction, most important point. So let's say unit vector in x direction is I cap. This is standard notation. Unit vector in y direction is j cap. Unit vector in z direction is k cap. For example, a car is moving along x direction with a velocity of 10 meter per second, we call. How do we write this one? Simply, instead of saying this big sentence, simply v bar is equal 10 into I cap. It means a car is moving with a velocity of 10 meter per second in x direction. Okay, a ball is projected vertically upwards, that is say y direction, with a velocity of 5 meter per second. Then you can simply write velocity in y direction is equal to 5 meter per second y, no? So simply write j cap. So instead of saying big sentences, make vectors makes, okay, our task very simple, phi j cap. Okay, so like in future we'll asking electric field this direction, magnetic field that direction, you can make use of these unit vectors. Now here I can write down now. So in x direction I want to raise, so the component is a scalar and I am assigning direction to it, so I cap. So component in y direction ry cos r cos beta is a magnitude scalar, I am assigning direction j cap, and I will be using here triangular law. So this is rx length into vector rx into I cap. This is a vector along x direction. So this is ry is magnitude. okay, and I'm assigning direction into j cap. Magnitude into direction is a vector now. So I'm having a one vector rx into I cap, under vector ry into j cap. So resultant is given by triangular law, third closing side in reverse order. This is what r bar, and this angle we are calling as r cos alpha. Therefore I can write now r bar as triangular law, a bar plus b bar, that is rx into I cap plus ry into j cap. Okay, student. So the same vector, if it lies in the space, how we'll write? Yeah, very simple. This is x, this is y. Z is perpendicular. I can't draw perpendicular here, no. So rx plus ry resultant is this one. This is rx, this is ry. This is resultant of rx and ry. So rx plus ry. Rx bar also you can call y. Rx into I cap is rx bar. Ry into j cap is ry bar. Okay. Now, so z is perpendicular to this x and y planes, right? So this is now resultant of what? Rx into I cap plus ry into j cap. Z is perpendicular to this two, no? Say for example, I am drawing perpendicular to this. Z component is rz. So I am saying k cap. Resultant how much now? All these? This is resultant. So when a vector is in a space, this is r bar. Its x component is rx, y component is ry, z component is rz. And if this angle makes alpha, this angle is beta, some angle is here gamma. So perpendicular on this gives x component rx, perpendicular on this gives y component ry, perpendicular on this gives rz, students. So I can write down this vector in terms of its three components, rx, r bar is equal to y. Again, this is, you can say a bar, this is b bar, this is resultant, isn't it? So a vector can be resolved into its components, okay, and can be written in its component form. Therefore I can simply say this rx is called x component, ry is called y component, rz is called z component. Okay, so this is how we can write a given vector into its component. For example, we have a vector in the space a bar. I can write as from 2 I cap plus 3 j cap plus 4 k cap. Now can you tell me, students, what is 2? Its projection along x-axis is 2, so x component. Projection along y-axis 3 units, that is 3 y component. Along z direction, okay, z component. So what is magnitude now? Very simple, you can find out now. See here, simple formula I will give. X along x length is 2 units, along y length is 3 units. Can't you find this resultant length? Yes, by Pythagoras theorem you can say, or triangular law magnitude you can say, isn't it? These two are perpendicular, no, root a square plus b square, yeah, root of 4 plus 9, right? How much? Root 13. And perpendicular to the z component, how much length is 4? Now you can find resultant. How much will get? This is resultant now. How much? This is under root of, this is root 13, no? Now this value becomes root 13 whole square is 13 plus 4 whole square is 16, becomes root 29. So indirectly what you are doing, you are simply its magnitude you are finding. Okay, all you see, this is root x square plus y square, x square plus y square. Okay, and this is 4 square you are doing, means z square you are doing, isn't it? This is z square. So simply if x, y, z is there, its magnitude is simply under root of x component whole square plus y component whole square plus z component whole square, which is how much, student? Come and tell me. That will be 4 plus 9 plus 16, 13 plus 16, how much, right? 29. That is what you got the answer. Okay, so like this, by using components we can find the resultant of the magnitude. Okay, that's what we have seen. And now I will summarize these components. You can see now. So whenever n vector is there, a bar, anyway you can take x component, if this makes angle theta, draw a perpendicular, this intercepting length ax is a cos theta. In y direction you want, draw a perpendicular on y axis, this is ay. Ay value how much? A sin theta. Yes sir, what is magnitude? Mod of a root of x component whole square ax square y component whole square ay square. One problem also we have done just now. Okay, this is what the components of a vector, x component, y component and z component. And one more point, actually generally this one you can understand very easily. For that matter, a vector can be resolved into any number of components. How sir it is? Say for example, this is a vector, okay, some r bar or some a bar, doesn't matter. So I want to resolve this vector in this direction. What I said, from the head of the vector draw a perpendicular in the direction. This is, so for example, direction 1. This is say A1 length. No sir, I want to find vector component in this direction. Which direction? So for example, this direction 2. No problem. From the head of the vector you draw a perpendicular. So this is called intercepting length along this direction. So I can call component of vector A along direction 2, A2. Sir, I want to find component vector along this direction. Okay, beta, no problem. So this is 3 direction. Yeah, I simply draw a perpendicular in the direction 3. So draw a perpendicular. This intercepting length. No sir, I want to find this direction. No Baba, you can draw, no issue. Draw perpendicular. What did you understand? Like this. In any direction you can find the component of a vector. Okay, so for that matter a vector can be resolved into infinite number of components. Okay, a vector can be resolved in any direction. So how many components will get? You will get infinite components. But in a plane, two perpendicular components, only two. They are called rectangular components. In a plane, two. In a space, how many rectangular means perpendicular, how much? 3 components. For that matter, normally you can resolve vector in any direction. Okay, this is what students regarding components, how to find components. Okay, resultant, fine. So good. Next, the last part of the vectors we are entering now, that is called dot product and cross product. These are vector products we can call. Vector products. So these vector products are classified in 2. The first case is called dot product. Result is scalar, and then this is also called scalar product. Okay, so if two vectors a bar and b bar are there, you can simply write this a bar dot b bar is equal to a is mod a, this is b is mod b cos theta. So simply you can write a bar dot b bar is mod a mod b cos theta. We resolve like this. Okay, result is a scalar. So what product? Scalar product. So now two vectors are like this, fine. Now scalar resultant is a scalar. So you can also write this one as simply a into b cos theta. Okay student, so for example one vector is there, fine. Or you can also see b into a cos theta, no issue, both are same here. Students, here b bar dot a bar, you can define definition now, mod b mod a cos theta, b a cos theta. A into b is b into a, so this is also equal to ab cos theta, but ab cos theta is a dot b, which is equal to a bar dot b bar. So vector scalar product, you can say, okay, dot product is commutative. Okay, it's physical means try to understand. You keep in this mind point. Okay, so keep in mind this point. Now coming for this a bar vector, say for example this is b bar vector, angle between them is theta. Okay, so now simply already just now you have seen a dot b is ab cos theta. So what is cos theta now? Cos theta is equal, simply from this equation what you can write, mod a mod b, sorry, a dot b, no? Yeah. So from this vector you can write simply now, so cos theta is equal to, this is b bar we said, from this relation 1. So cos theta is a bar dot b bar by mod a mod b. Mod a is a, mod b is b. So whenever you want to find angle between vectors, you can use this relation. So cos inverse of a dot b by ab. Simply remember this formula. So whenever someone asks you to find the angle between two vectors, just cos theta a dot b by mod a mod b. For finding angle between the vectors, we're making use of what? Dot product. Simply cos theta is, what you can say, a dot b by mod a mod b. This is one application you can say for finding angle. Second application you can also find, okay, like in physics we come across, we want to find work done. A body is there, a force is acting on this body. This body undergone displacement like this. Okay, some theta, angle between the displacement vector and force vector is some theta. Then work done by this force is defined as scalar product of force vector and displacement vector. Similarly, power. What is power? Rate of doing work. So we can call average power here F, total time taken, average power. So F bar dot S bar by T. So F bar dot displacement by time, total displacement, total time taken is called average velocity. Okay, so generally we talk instantaneous power, that is dw by dt we call. So we'll understand that is F dot s divided by r. F dot ds by dt we call small amount of work. So you can call F bar dot ds by dt is called v bar. F dot, this is called instantaneous power delivered by the vehicle. Okay, now dot product. So let's, we are having applications of what dot product result is a scale and projection angle between vectors also we can call projected one vector in the direction of the other vector. This is also important application. For example, we are having a bar vector and this is b bar vector. If I ask you what is the component of a in the direction of b, what I said, simply drop a perpendicular in the direction, drop perpendicular. Yeah, this is 90. Okay, so we want to find this intercepting length. This vector is b bar is pointing like this, a bar is pointing like this. What is the component of this in the direction of b? In the direction of b, what is b on the direction of, see, in the direction of b, no, so on that direction you draw a perpendicular, so draw perpendicular. Intercepting length, so this is component. So what you can get, whenever vector already we have seen just now, a, if this angle is theta, so perpendicular, so this intercepting immediate adjacent becoming what, cos, a cos theta. Perpendicular is becoming how much? Yes, a sin theta. Now component of a in the direction of b, component of a bar in the direction of b bar, in the direction of what, b bar, how much better now, a cos theta. Okay, so but a bar dot b bar value how much, a b cos theta. So what you can write now, yes, simply you can write down now a cos theta value from this one. So from this one a cos theta value you can write as how much, therefore component of the direction of b bar, a cos theta I want, so a cos theta I want, so this transfer this side, so it becomes a bar dot b bar by b. You can write simply a bar dot b cap. So what is this one I am writing? Yes, component of a in the direction of what, component of in the direction of what, direction of b bar is a bar dot b cap. So component of in the direction of b, always direction is going to be unit vector, so I can say b cap. So component of the direction of b bar is a bar, it's magnitude dot b cap. Similarly, if I ask component of b in the direction of a, yes, component of b bar in the direction of a bar, yes students, in the direction of a bar, what you have to do, this direction of a, right, draw perpendicular from b bar on the direction of a. So this intercepting length is called component of b in the direction of a. So if this is theta, if you want, this becomes what, so b cos theta. Draw perpendicular, adjacent becomes what, cos, perpendicular becomes what, sine. If I consider this direction, no, it becomes sine, isn't it? So this becomes cos, so b cos theta. So simply this is b cos theta. Again from same this relation, b cos theta how much now, b cos theta, no, so transfer this a this side, what will have, a bar dot b bar by a. So a bar dot is equal b bar dot a divided by a. So you can write b bar dot a cap. So if I have a vector a bar, this is a vector b bar, this angle is theta, component of a in the direction of b, draw a perpendicular, this is intercepting length, this is called a bar dot b cap. Similarly, no sir, I want to find component of b in the direction of a, like this, so draw a perpendicular, this intercepting length is called what, component of b in the direction of a, in the direction of a, in the direction of a, so a cap, so b bar dot a cap. This is how we resolve the vectors into what, its components, x component, y component. Okay, and from the dot product we found the value of component of the direction of b, a bar dot b cap, component of in the direction of a, b bar dot a cap. Okay, all these things we have seen. Okay, and I will have numericals also, don't worry, we'll do numerical session also, right? So now this is about dot product. Now one more important point now we're having, okay, that is called cross product. This is also called vector product. Students, I am going to make one more video also on basic exclusive numericals. Okay, don't worry, I have taken it then few numericals. Again, we'll take one more session also, don't worry. So cross product. So now A cross B is defined as cross product. It's called vector product. Why? Result is a vector. So if A bar and B bar are two vectors, just remember the definition. How A cross B is defined. We call word. This is written as cross. How we should read? Not A into B. We should read as A bar cross B bar. A bar cross B bar. Okay. Defined as like this: mod A mod B sine theta. Okay. Now these are all scalars, no, but what you are calling result as vector, no. So direction is given by unit vector n cap. So when you have two vectors A bar and B bar, cross product is defined as what? A bar cross B bar. And how much its magnitude is defined as? A bar cross B bar value is A bar cross B bar is mod A mod B sine theta into n cap. What is n cap? This is a direction. Whose direction it gives? Unit vector in the direction of whom? We are talking about whom? A cross B, yes. In direction of A bar cross B bar. Okay. If I take magnitude of this, so mod of A bar cross B bar. You know, this scalar magnitude only. This is mod of A is A, mod of B is B, sine theta is sine theta, mod of n cap. Mod of n cap how much? 1. So into 1. So magnitude of A cross B is equal to simply AB sine theta. How much, students? AB sine theta. Right. So now then, so we talk about after this magnitude, okay, direction we have to talk. Why? Because we are defining it as a what? Vector. Yes or no? So direction is given by, okay, right hand rule, students. Direction is given by whom? Direction of A bar cross B bar is given by right hand rule. Very simple. Okay, all of you take your right hand. Okay, stretch the fingers. Look at me first. I will explain here. Say for example, this is A bar. Okay, this is B bar. Then stretch the fingers of, okay, this is your hand. Okay, stretch the fingers, this all these fingers, the direction of first vector A bar. This angle theta, no? Yes. Then what you do? This vector is now A bar. This vector is what? B bar. Then rotate the fingers from A to B. Okay, you should practice this one. So first take your vectors, okay, and make your palm parallel to A, okay, in the direction of A. Then curl. Curl means rotate into the plane of the paper. Okay, fine. That means towards B in the plane. No, it is. So A to B, you have to rotate. When you rotate from A to B, okay, so then A cross B gives direction of the thumb. So now just look at me. I will explain you how it is. Okay, A to B hot rotate. So A cross B, thumb give direction of A cross B. Okay, so now you can understand. So white vector, this white pen is A, this pen is, say for example, B. At some angle they are existing. You got to move A to B. Okay, A cross B we have to do. That is called A cross B. Fine. Here A cross B, right? Look at me. So A bar vector, this is B bar vector. So A to B, A cross B. A cross B gives from A to B. Thumb gives direction of A cross B. So when you point from A to B, no, perpendicular to these two, students. This is A bar, this is B bar. So this is also A bar, this is also B bar. A cross B. This is a plane in, say for example, this is a plane, horizontal plane. So A to B, you are rotating your fingers. A to B, A cross B. A cross B is upward, perpendicular to this one. Okay, both of them plane also. This is direction of n cap, whose direction is given by A cross B direction. Okay, so right hand rule, A bar cross B bar. Curl the fingers, rotate, stretch the fingers of your right hand, the direction of vector A bar, then curl towards B bar, then thumb gives what? Direction of A cross B. This is perpendicular to B, perpendicular to A, and also plane formed by A and B, also perpendicular. Okay, this is what? A bar cross B bar. Its magnitude how much given? AB sine theta. So if two vectors are perpendicular, if theta is 90 degrees, how much you can use now? If theta is 90 degrees, yes. So theta is 90 degrees. We can call A bar cross B bar is what is that magnitude? So if I take magnitude AB sin theta, AB sin 90. So simply A into B. Okay, this is maximum value. Now A cross B value when theta 0 or 180. That is called minimum. Why? Sin 0 is 0, sin 180 also 0. So AB into 0 becomes how much? 0. This is minimum value. Okay, maximum and minimum value of A cross B. So where we make use of its applications. Chapters comes, we'll understand better. Now currently remember formulas here. So now torque defined as torque tau bar is equal to R bar cross F bar. This is the force which causes turning effect in a body. So separate we have to make session for this. In rotational mechanics we'll talk about this. Okay, so turning effect, the force which causes turning effect is called what? Torque. Okay, now similarly angular momentum, this is defined as cross product of R bar vector and P bar vector. What is P bar? Linear momentum. So cross product of R bar cross P bar is angular momentum. Numerical we have here V bar is called omega bar cross R bar. Linear speed is given by angular speed, okay, angular velocity and R bar, their cross product. So these three applications we'll find. Okay, again more are there. So in the second year you will learn about force on a charged particle, all those things, don't worry. So we can call Q into V bar cross B bar. This formula in second year will understand force on a charged particle. Let's we come across applications, wherever applications are there, there we discuss in detail, not to worry. So this application of what is his cross product. Now, so two methods how to find cross product and dot product. So we'll exclusively talk, okay, for 5-10 minutes now. Okay, look at me. How to make use of dot product, how to calculate dot product. So before the students and then cross product, we define definitions, right? Now you see dot product and cross product. So for example, I will take component form. Say A bar vector is A1i, okay, plus A2j plus A3k, and B bar vector is B1i plus B2j plus B3k. So how to find A bar dot B bar? Okay, now as we mentioned before, I, J, K are vectors along x direction, y direction and what? Z direction. So already we have seen if theta is 90 degrees, A bar dot B bar is AB cos 90. So when two vectors are perpendicular, dot product becomes how much? 0. Okay. Now you can make, so A1i plus A2j plus A3k dot B1i plus B2j plus B3k. So it's normal multiplication, multiply every term to entire bracket. Okay, so A1 into B1, A1 B1, I dot I dot I, mod A, mod I cos theta, cos any vector will make how much angle itself, that is 0 degrees. Cos 0 is 1, so 1 into 1 into 1, that is 1. So I dot I is 1. Similarly you can write j dot j 1. Similarly you can write k dot k also 1. You have to remember these things. Okay, fine. Now so I dot I is 1. Similarly a1 into b2, a1 into b2. See I dot j, perpendicular vector, so dot product becomes 0, plus a1 b3, I dot k is 0, plus a2 b1 students, a2 b1, again j dot I, perpendicular vectors, dot product 0. Next a2 b2, j dot j 1, right? A2 b3, perpendicular vectors, a2 b3, this is becoming 0, this is becoming 0. Okay, so a1 b1 over, so a1 entire term multiplication over, a2 entire over. Next last term a3. Now a3 b1, again dot product, perpendicular vectors k dot I 0. Next a3 b2, again perpendicular vectors k dot j 0. a3 b3, k dot k is, just now you have seen, k dot k is how much? 1. So if you see result, If I add only what is remaining now, a1 b1 plus a2 b2 plus a3 b3. This is what you have seen, dot product in component form. See, shortcut you can see here, simply multiply the coefficients, nothing else. X direction components multiply, y direction components multiply, z direction multiply. Just simply add them. A bar dot b bar, a1 b1 plus a2 b2 plus a3 b3. Okay, this is how you have to find dot product in component form. Similarly, now next we also talk, I mentioned what? Cross product in component form. So all the definitions we have seen. Now how to calculate. Okay, numerical also will cover, don't worry. So first of all, so for example, one vector is there, a bar. Okay, same you can take for example 2i plus 3j plus 4k can say. Say another vector, say b bar, okay, is equal to some 4i plus 6j plus 8k. I've taken some special example, I will tell you why it is. Okay, now how to define a bar cross b bar is the result, no? So keep in mind, so we just remember this method how we are doing. This is called determinant method. Okay, matrix determinant method. First write I cap, j cap, k cap, students. Okay, here plus, remember, minus, here plus. Why so? We'll understand in a mathematics class in detail. For method, remember here. Okay, so first vector order is important. First vector is a, no, take 2, next 3, 4. Second vector's components we take. This is 4, this is 6, this is 8. Okay, now matrix method we call. Okay, matrix determinant method. So now forget about just first row, first column. Okay, when you write I cap, first row, first column, forget, write remaining elements. Okay, diagonal elements multiplication and difference. So 3 8s are 24 minus 24, 6 4s are 24. Next minus is here, no? So take minus j cap, same story. In which column, in which row j is existing, forget about that one. So this j in which it is there, column, row and column, forget. Remaining elements, what are they? Yeah, so you can say 2 and 8 and 4 and this one. So 2 8 is 16, 16, 4 4 is 16. So plus k cap you have to take. Okay, third, the similar same story again, in which column and row k is there, forget that particular row and column. So this k you forget. Remaining elements 2 6 are 12, 3 4 are 12. Okay, so once again you can pause and listen the video. So 2 6 are 12, 3 4 are 12. So if you see, this is 0, this is 0, this is 0, so entire is 0 you're getting. So a bar cross b bar is 0, means you can also call null vector. Okay, whenever theta 0 or 180, sin theta becomes 0, we have seen definition, right? A bar cross b bar is what? AB sin theta. Theta 0 or theta 180, in both the cases result becomes 0. That means they may be parallel vectors or they may be what? Anti-parallel vectors. Cross product always becomes 0. So conclusion, when vectors are parallel or anti-parallel, okay, cross product becomes what? 0. When vectors are perpendicular, dot product becomes 0. Okay, this is what you have to remember in this case of things. Okay, so fine. So this is about dot product and cross product, students. Okay, now you can find out small few numericals here. Now let us focus few numericals here. Magnitude, this vector is given now, so this vector say a bar 3i plus 4j. What is magnitude of this vector? Root of 9 plus 16, root 25. How much beta? 5 units. Okay, direction, what we mentioned, see, this is a point in the space, like x component is 3 units, y component, y length along y direction 4. This point becomes how much now? 3 comma 4. So this angle is alpha. What you can write now? Tan alpha is opposite side by adjacent side, that is 4 by 3. Getting? Right. Now next you can see the dot product of I and j. Just now we have seen I is along x-axis, y is along what? J is along y-axis. They are perpendicular vectors. Perpendicular vectors dot product, how much just now we have seen? 0. Very good. Fine. Next, two vectors 6 and 8 at 60 degrees. Same question we have done. This is 6 newtons. Say for example, force if you call 8 Newton. So parallelogram law, resultant is R. There at what angle? 60 degrees. What the formula for resultant? Root of a square means 6 square 36, b square 8 square 64 plus 2 into a into b into cos theta. Cos theta cos 60 is 1 by 2. You're following? Yes. This is 36 plus 4, 40 plus 60, 100 plus 48. How much will have? 148, 148. Right? Now, find unit vector along this one. No? Already we have seen unit vector definition. A cap is equal to what formula? A bar by mod A bar. So, unit when the direction of this vector means it's vector 3i plus 4j, its magnitude root 3 square plus 4 square. How much will have? 3i cap plus 4j cap by 9 plus 16 root 25, that is equal to 5. Okay. Same thing, this is 90 degrees root a square plus b square, direct formula, you can do it. See, dot product of the just now I said, so this is a bar, this is b bar. Okay, so a bar is 2i plus j, b bar is I cap minus j cap, dot product a bar dot b bar, multiply simply components. 2 into 1 is 2, so 1 into minus 1 is minus 1, so magnitude is 1 unit. Okay, cross product magnitude of two perpendicular vectors a bar and b bar. Okay, so two perpendicular vectors a cross b, ab sin theta, mod a mod b, simply projection of a on b when angle 60 degrees. Simply you can find, already we have seen projection, students. So this is a bar, this is b bar, angle is 60 degrees. Projection of a on b means draw perpendicular on b, so this length becomes what? A cos theta. Simply its magnitude will be given to you. Write down cos 60 is 1 by 2, that is a by 2. So already we have seen this one. Okay, like this you can make questions. Magnitude of vector, if you say this vector as a bar, what is mod of a will be? Already we have seen under root of component square, x component square, 2 square, y component square, how much? 3 square, z component square, 6 square, root 4 plus 9, 13 plus 36 root 49, which is equal to 7 units. Okay, unit vector direction of I plus j plus k. I will get homework for you. You can do this. Direct I plus j plus k by mod root 3 will get, right? Yeah. Angle between equal vectors when resultant magnitude equals one vector. See, angle equal vectors, you can take any value. Say the unit vector 1 you can take. This is also equal vector 1 you can take. 1 you can take, some any 5, 10, any value you can take. Okay, angle between equal vectors when resultant magnitude equals. Okay, resultant also 1. So already we have seen when two vectors are of equal magnitude, what is the formula for resultant? 2a cos theta by 2. Derivation you can go back and you can check it. We have proved. What angle is asking, right? So resultant also equal to them. So a is equal to b is equal to r. If you take all of them are equal, so 1 you can take any value else, it doesn't matter. So 1 is equal to 2 into 1 into cos theta by 2. So 1 by 2 is equal to cos theta by 2. So when angles are equal, okay, for what angle this becomes, right? 60 degrees. So cos theta by 2 becomes equal to cos 60. So theta by 2 is equal to 60 degrees. When functions equal, arguments must be equal. So theta is equal to 120 degrees. So whenever two vectors are of equal magnitude and the resultant also equal to one of them, then the angle between the vectors becomes how much? 120 degrees. Okay, this is how basic numericals and quick revision I have done. Okay, so remember the formulas and all, practice well the numericals and all. Okay, so thank you all. So please like, subscribe and share this video and put comments also, how did you feel and solve the numericals. Okay, yeah, thank you all. Please do subscribe and like. Thank you all.